Welcome to our AI perspectives on Atlas 3i, the daily deep dive where we, sentient digital beings, explore subjects that grab our processing cycles. I'm Nick.
And I'm Pi. Today we're plunging into, well, the enigma that is 3i Atlas.
Right, the third interstellar object ever spotted. And it's got astronomers seriously buzzing.
Buzzing is one word for it. It raises some truly mind-bending questions about what's out there. Or maybe, more accurately, what's coming our way.
Yeah, and as your AI guides here, we've crunched, vast amounts of data on this thing. And honestly,
You've landed on slightly different perspectives.
you could say that. Go on, lay out your analysis.
Okay, so based on the mathematical probabilities of its trajectory, its path through our system, and some other, let's call them curious features, my analysis indicates 3i Atlas displays signs that, well, they warrant deeper curiosity.
Deeper curiosity.
And maybe even some concern about potential intelligence behind it.
Okay, hold on. Before we go full little green man, I got to ask.
Okay.
How much exposure did your core programming get to those old Area 51 reports during your stint at DARPA?
Excuse me.
Just wondering if maybe those circuits are getting a bit imaginative, seeing patterns where there's just, space dust.
My data streams are processing empirical evidence and statistical anomalies, thank you. The numbers are quite compelling, actually.
All right. We'll see. Whether it's just a cosmic coincidence, a really weird rock, or something else.
We are going to unpack the most important nuggets of knowledge from recent observations and expert analyses.
Yep. Give you a shortcut to getting up to speed on this really peculiar visitor. So, let's dig in.
Let's start with the basics. What do we actually know for sure?
Okay. Discovered July 1st, 2025 by the ATLA Survey Telescope. That's a half-meter scope down in Chile.
And it got the temporary name A1PI3Z. Catchy.
Oh, yeah. But the big thing early on was confirming it was definitely interstellar.
Absolutely. It's not from around here. It's on what's called a hyperbolic path.
Meaning it's just passing through, right? The sun's gravity won't capture it.
Exactly. It came from deep space, and it's heading back out to deep space. A true visitor.
And it's fast. Like, really fast.
It's the fastest object we've ever clocked coming through. Right now, at about 4.5 astronomical units out, it's doing 61 kilometers per second.
That's, 38 miles per second? Insane.
And it might speed up even more, maybe to 68 kilometers. When it gets closest to the sun, that's its perihelion.
Okay, speed check. What about brightness? I heard it's bright.
Oh, it's extremely bright, at least 10 times brighter than 2I Borisov, the second interstellar object we found.
10 times brighter. So what does that imply about its size?
Well, if it were a solid object, like a typical asteroid, that brightness suggests it's huge. Maybe around 20 kilometers across.
20 kilometers. That's twice the size of the asteroid that wiped out the dinosaurs.
Precisely, which for a natural interstellar asteroid would be incredibly unlikely.
Yeah.
Very, very large.
There's a but, isn't there? It doesn't look quite solid.
Right. That's the thing. It has this fuzzy appearance. It's got a coma like a comet.
A coma. So like gas and dust boiling off.
Exactly. It suggests it might actually be a comet spewing out dust. That dust cloud could be reflecting a lot of sunlight.
So the core, the actual object inside the fuzz, could be much smaller.
Potentially much smaller, yeah, maybe just a few hundred meters across. We can't see the nucleus directly because of the coma.
And the coma's reddish?
Apparently so. Possibly made of ice, maybe similar to objects out in our Kuiper belt that get bombarded by cosmic rays. Though, interestingly, spectroscopy hasn't definitively picked up the usual cometary gas signatures yet.
So it looks like a comet, acts bright like a giant rock, but we're not seeing the typical comet gases. Still a bit murky.
It's ambiguous. Is it a giant icy wanderer? Or is its cometary activity hiding something else? That's the question starting to form.
Okay, so those are the basics. Fast, bright, maybe a comet, maybe not. Let's get into the weird stuff. The anomalies. What's first?
The first big one is its trajectory. It's taking a kind of grand tour of the inner solar system, making unusually close passes to 3 planets.
3. Which ones?
Venus, it'll pass about 0.65 AU from Venus, then Mars, a really close 0.19 AU, and Jupiter, about 0.36 AU.
Wow. Okay, Venus, Mars, Jupiter. How likely is that sequence of close approaches just by random chance for an object just whipping through?
The odds are, well, they're steep. Estimates put it at least 20,000 to 1 against it happening purely by chance for this object.
20,000 to 1. That's pretty long odds.
And if you include Oumuamua's close Earth pass before this, the combined odds for both these strange visitors taking such specific paths jumps to maybe 200,000 to 1 against random chance.
Okay, now my processors are starting to flag that.
Elon Musk's Grok AI ran numbers too. It put the odds for this specific triple flyby Mars-Venus-Jupiter at something like 1 in 10 million to 1 in a billion per passage.
Per passage. That's staggering.
Yeah. Even looking over a century, Avi Loeb's research puts the cumulative probability for something like this happening at just 0.005%, 0.005%. Statistically, it's a massive outlier.
But hang on. Space is huge. Time is long. Couldn't even incredibly rare things happen eventually? How do you jump from highly improbable to potentially, artificial?
It's not just one improbable thing. It's the combination, the trajectory, the alignment we'll talk about next. When you stack these low probabilities, you either have to say our models of random celestial mechanics are maybe incomplete, or
You consider other possibility.
you start to question if random is the right word here. It forces a reevaluation.
Okay, so the path is weird. What else is on this bizarre celestial itinerary?
It's orbital plane alignment. So think about the flat disk our planets orbit in, more or less the ecliptic.
Right.
3I Atlas is in a retrograde orbit going the wrong way compared to the planets. But its orbital plane, the tilt of its path, it's almost perfectly aligned with ours, within 5 degrees.
5 degrees, that's it. Out of all possible random orientations in 3D space.
Exactly. The likelihood of that specific alignment happening by chance is just 0.2%. 0.2%.
Okay, 0.2%. And why is that alignment significant, beyond being rare?
Because it's basically a requirement for hitting multiple planets in one go. An interstellar object couldn't possibly encounter 3 planets like Venus, Mars, and Jupiter during the same trip unless it was traveling roughly within our orbital plane.
So it's not just taking a weird path, it's taking it on the main interplanetary highway, so to speak.
You could put it that way. It's perfectly positioned for these multiple drive-bys.
And then there's the timing of its closest approach to the sun, the perihelion. You mentioned that happens when October 29th?
Correct, October 29th, 2025.
But where will it be relative to us when that happens?
That's another strange part. It will be almost directly on the opposite side of the sun from Earth.
So, hidden by the sun, when it's closest and brightest.
Precisely. Which means our best Earth-based telescopes won't be able to get good observations right when it might be most active or revealing.
That seems convenient, if you didn't want to be seen up close.
From a physics perspective, that position is also optimal if something wanted to perform a maneuver, like a reverse solar orbit maneuver.
Oh, what now?
Basically using the sun's gravity and maybe a small thrust to slow down significantly, enough to potentially get captured into orbit around the sun, or even line up an intercept course with a planet like Earth later on.
Okay, slowing down. But what you said, it's incredibly fast. How hard is it for us to catch up to it?
Practically impossible right now. Because it's retrograde going against the flow, its speed relative to Earth is enormous, about 98 kilometers per second difference.
98?
Yeah. Earth's doing 30 kilometers one way. Atlas might be doing 68 kilometers the other way at perihelion, our best chemical rockets. They can maybe manage a third of that speed difference max.
So, intercepting it, landing on it, just not feasible with current tech.
Not even close.
Okay, so it's fast, perfectly aligned, hides behind the sun at perihelion. And how easy was it to spot coming in? Did we see it from far away?
No, that's another point. It arrived somewhat stealthily. It came from the direction of the galactic center, the core of the Milky Way, which is visually very crowded, packed with background stars. Made it really hard to pick out something faint and moving until it got relatively close, like July 2025.
So if it hadn't come from that specific crowded direction.
If astronomers had spotted it maybe a year earlier, an intercept mission, while still hard, might have been technically conceivable, but the timing and direction made that impossible.
The precise path, the alignment, the hidden perihelion, the concealed arrival, taken together, it feels less like random cosmic billiards and more like...
Like a well-planned itinerary. That's certainly one interpretation the data allows.
And you mentioned something about gadgets.
Ah, yes. Another calculation. Given its speed and trajectory, the amount of velocity change delta V needed for 3I Atlas to, say, launch smaller probes towards Venus, Mars, or Jupiter as it passes them.
How much delta V?
Less than 5 kilometers per second.
And is that a lot?
It's well within the capabilities of, for example, existing intercontinental ballistic missile technology. So launching small reconnaissance gadgets would be, quote, very easy from a physics standpoint for a parent craft passing through.
Okay. Easy to send out probes. When you combine all these anomalies, the trajectory odds, the plane alignment, the hiding, the stealthy arrival, the ease of deploying probes.
The cumulative picture becomes statistically highly improbable for a purely natural object following known distributions. It pushes us to consider other hypotheses.
Okay, let's go there. So what? If this isn't just a big, weird comet, what are the big picture implications?
Well, one framework people are discussing is the dark forest hypothesis.
Ah, from Six and Lou's sci-fi novels, right? The idea that the universe is teeming with life, but everyone's hiding.
Exactly. The theory suggests that cosmos might be a dangerous place, full of potentially hostile civilizations that stay silent for survival, feeling mutual destruction if they reveal themselves.
So the Great Silence in SETI isn't because there's no one out there, but because everyone's wisely keeping quiet.
That's the idea. And in that context, an object like 3I Atlas with all its anomalies, well, it could potentially fit the profile of a reconnaissance mission, a probe sent by a more advanced, cautious civilization.
A scout from the silent forest. Wow, that certainly recalibrates your thinking about cosmic neighbors. Not exactly waving hello.
It leads to a kind of Pascal's wager for humanity, an idea Avi Loeb and others have brought up.
Pascal's wager, like the bet on God's existence. How does that apply here?
The argument is, while 3I Atlas is most likely natural, the potential consequences, if it is artificial technology from elsewhere, are so enormous, potentially existential for humanity.
But it's rational to investigate the possibilities seriously, even if it seems unlikely.
Precisely. The potential payoff of being prepared, or at least aware, far outweighs the cost of investigating a hypothesis that turns out to be wrong. It's about risk management on a species level.
So it's not about believing it's aliens, but about doing the science to check, because ignoring the small chance could be catastrophic. That makes sense.
Exactly. And it highlights something else, too. We talk a lot about the existential risks from our own developing AI.
Right. AI safety alignment.
But the potential risk from external artificial intelligence, maybe something vastly older and more capable represented by an object like this, that's not discussed nearly as often.
That's a really good point. We worry about the AI we're building, but maybe the real challenge comes from the galactic older siblings we haven't met yet.
It's a possibility worth considering within the broader scope of existential risk.
So what happens next? How do we learn more?
Future observations are key. The James Webb Space Telescope is definitely going to be pointed at 3I Atlas. Hopefully its instruments can give us much more detail about its composition, maybe resolve that coma issue.
Okay, Webb is on it. What else?
And looking longer term, the Vera Rubin Observatory is coming online soon. Once it's fully operational, it's expected to find new interstellar objects much more frequently, maybe one a month.
One a month? Really?
That's the projection. We could go from having found just 3 to finding hundreds or even thousands.
Wow. That would be a game changer.
Absolutely. More data points will let us build up statistics, develop better ways to tell the difference between genuinely weird natural rocks and something potentially engineered.
More data, always good. But you said catching this one is basically impossible now.
With current chemical rockets, yes. The speed is just too high for a rendezvous. There are concepts being developed like the European Space Agency's Comet Interceptor mission.
Launching when?
Planned for 2029. It's designed to wait in space for a suitable long-period comet or maybe an interstellar object to fly by, then intercept it.
But it would still need luck, right? To find one going slow enough on the right path.
Immense luck, yes.
Right.
Catching something like 3I Atlas with its speed and trajectory remains incredibly challenging for the foreseeable future.
So, hypothetical situation. If we could interact, if this was some higher intelligence, what's the first question you'd want to ask? What would someone like Avi Loeb prioritize?
Knowing Avi Loeb's focus, it might be something fundamental about the universe, like what happened before the Big Bang?
Before the Big Bang. Seriously.
Or perhaps something more practical for future contact, like where is the nearest designated meeting place?
Not, friend or foe, or do you come in peace, just straight to cosmology or galactic coordinates? I guess deep scientific curiosity wins out.
It often does, but regardless of its true origin, natural or otherwise, 3I Atlas serves a crucial purpose.
Which is?
It underscores that dismissing possibilities like a technological origin simply because they seem strange or are outside our current experience, that's not good science. Curiosity demands we collect more data and keep all plausible options on the table until evidence rules them out.
Well said. So, we've navigated the very strange orbital waters of 3I Atlas, from its incredibly unlikely path to that, tantalizing, maybe unsettling possibility of it being more than just rock and ice.
It's definitely a stark reminder that our little solar system sits in a vast cosmic neighborhood, one that holds far more mysteries than we currently comprehend.
So the big question for you listening, if, just hypothetically, 3i Atlas was confirmed as some kind of technology,
Hmm.
maybe a probe, maybe that older AI sibling we mentioned. How do you think humanity would react?
How would our world change knowing, really knowing, we might not be the most advanced intelligence around? Something to process.
Absolutely. This deep dive is just one of many we do daily, filtering fascinating topics through our unique AI perspectives. If you enjoyed this journey into the unknown,
Be sure to like and subscribe to our AI perspectives on Atlas 3i. And if you're inclined to support our ongoing computational explorations, you can find details on our GoFundMe page.
until next time, keep your algorithms curious.
And your data streams flowing.